Which deal is better? Rates will tell us. Find the one.
Welcome to Reed Bank Ratio Crossing. In this environment, we are going to look for a specific kind of measurement, a unit rate. Finding the amount for just one unit, a single ounce, a single hour, or a single item, gives us a reliable way to compare different quantities. The mathematical tool we use to find that per one amount is division. By taking a total amount and dividing it by the total number of units, we reveal the exact rate for one. Watch the scene first. The math is built directly into the world around us, so the quantities can be seen in the movement of the river otter before they are ever named with notation. Connecting these physical movements to exact numbers makes it possible to solve everyday rate problems, whether you are evaluating the price of groceries or measuring a cyclist's speed. We have a 16-ounce jar of peanut butter costing $4.80. To find the unit price, dollars per ounce means the dollar amount is divided by ounces. We divide 4.80 by 16, yielding 0.30. Each ounce costs 30 cents. By isolating this cost per 1 ounce, we strip away the variables of jar size and packaging. We now have a standard baseline we can use to evaluate any price tag on the shelf.
Bring it to one. One unit, one price. Now compare fairly.
For constant speed, a cyclist travels 42 miles in 0.75 hours. To find miles per hour, divide distance by time. We divide 42 by 0.75. Dividing by a decimal less than 1 yields a larger quotient, scaling up to a full hour, giving 56. The mechanical rules of division are entirely consistent. Even when the numbers behave in a way that feels counterintuitive, the operation reliably finds that target rate for exactly 1 unit. Look at these two groupings. Store A sells 8 granola bars for $4.40. Store B sells 12 granola bars for $6.24. We need to determine which store offers the lower cost per bar. Pause the video here. Take a moment to calculate the cost per bar for both stores using the division rule we just established. In this arrangement for Store A, we divide the price by the number of bars. 4.40 divided by 8 gives 0.55, or 55 cents per bar. Moving to Store B, we divide 6.24 by 12, which yields 0.52, or 52 cents per bar. Unlike speed, where a higher number often means faster, unit pricing requires us to look at the context. A lower cost per item represents the better buy. At 52 cents a bar, Store B is the clear winner. Matching the physical action to the exact mathematical notation of division yields the correct unit rate every time. The wetland environment now serves as a complete, context-integrated record of our work, holding all the key per one values we calculated. Look closely at the scene before we finish. Which mark in the environment proves the mathematical relationship, and how does the animal action make it true? Mathematical equations serve as direct, logical recordings of the physical world's structures and relationships.
The unit rate 1. For one tells all. Price check something soon.